Welcome to qnawire.
Hi, so over here we're given that a certain enzyme is going to have a value for catalytic constant of 600 seconds to the minus 1 for the transformation of blue into red. We're given that the total enzyme concentration would be equal to 20 nanomolar, and the concentration of the substrate, which is going to be blue, is going to be equal to 40 micromolar. We're also told that the initial velocity for the reaction is going to be equal to 9.6 micromolar. Micromolar, in this case, it is not stated, but it should be micromolar per second in order to get our result. And remember that we are going to use the Michaelis-Menten equation. So, in this case, the Michaelis-Menten equation, under the conditions for which the concentration of the substrate is much smaller than the value for Km, the equation that we can apply is that the initial velocity is going to become the catalytic constant divided by Michaelis constant times concentration of the substrate times the total enzyme concentration. So in this case, we want to know what is going to be the value for Km, which corresponds to K catalytic divided by initial velocity times the concentration of the substrate times the concentration of the total enzyme that we are going to have. So replacing the values, we get 600 seconds to the 600 seconds to the minus 1. We're told that the initial velocity is of 9.6 micromolar. So remember that micro is going to correspond to 10 to the minus 6 molar. And the other quantity that we have is nano, which is going to correspond to 10 to the minus 9 molar. So we're going to get over here 9.6 times 10 to the minus 6 molar per second, or if you want, molar second to the minus 1, times the concentration of the substrate, which is 40 times 10 to the minus 6 molar, times the concentration of the enzyme, which is 20 times 10 to the minus 9 molar, which is going to give us a value for Km equal to 5 times 10 to the minus 5 molar. So in this case, what we see is that this value is going to be comparable to S, to the concentration of the substrate. In this case, the concentration of substrate would be equal to 4 times 10 to the minus 5 molar. So making this approximation makes not much sense, right? So we need to employ the full Michaelis-Menten equation, which tells us that the initial velocity is going to be equal to K catalytic times concentration of the substrate divided by Km plus concentration of the substrate times the total enzyme concentration. So in this scenario, what we need to do is to solve for Km, which gives us Km times B0 plus plus B0 times S is going to be equal to kcat S times total enzyme concentration. So Km would be equal to K catalytic times concentration of S times total enzyme concentration minus B0 times the concentration of the substrate divided by the value for B0. So replacing these values, 600 seconds to the minus 1, concentration of substrate, which we mentioned that was 4 times 10 to the minus 5 molar, times the total enzyme concentration, which was 20 times 10 to the minus 9 molar, minus B0, which was told to be 9.6 times 10 to the minus 6. I'm going to put the multiplication over here since I ran out of space, times the substrate concentration, which is, again, 4 times 10 to the minus 5 molar. Remember that this is molar per second. All of this over my initial velocity of 9.6 times 10 to the minus 6 molar per second, which is going to give us the correct value of the Michaelis constant of 1 times 10 to the minus 5 molar. And with that, it would be all. Thank you very much and have a good one.